Okay, this is AP Physics, of course, Unit 2, Dynamics. Review multiple choice question number 23. So right away I have two blocks and it has an additional force of 20 newtons pushing it to the right. We have a frictionless floor, and what they want to know, what is the force that the 8 kilogram mass exerts on the normal force? First we got to understand what that is, and what it is remember, a normal force is the ground pushing up on each other because it's two surfaces in contact. There is a normal force, think of it that way, of this block pushing on that one. That's what they want to know. They want to know what that normal force is that exerts on it. And I'm going to call that F of B in this problem. So let's start out with our force diagrams. So I'm going to do the 2 kilogram block, do the force diagram for that. And of course, I have the floor pushing up on it, the normal force. I have the weight, and I'm going to call that a 2 to keep track. It's a kilogram one. I've got the 20 additional force. I'm going to call that F of 20, pushing against it. And then the one I want to know is F of B. This block resisting when this one pushes against it, and that's a normal force again. So I'm going to call that F of B, like I said earlier. Let's do the free body diagram for the 8 kilogram one. And what it has, equal and opposite reaction. So if it's pushing back, this one is pushing on it. That would also be this block pushing back on that one, and those two have to be equal to each other. And then of course we have our normal force of the ground and of the force of weight of the 8 kilogram one. So if I write my equation out for what's happening here, I am going to have, and I'm going to have my positive direction going to the right in the normal situation. So I've got 20, force of 20, minus F of B, the one I want to know, and equal to mass of my 2 kilogram and acceleration. If I solve for F of B, I'm going to have F of 20 minus there. I do the same over here. I am going to have F of B as my only force, and that is equal to the mass of the 8 kilogram times acceleration. We agreed that this has to be the same for both of those. So if I set this up to each other, I'm going to have the mass and acceleration there. I'm going to solve for acceleration because I know this. I know my masses. The only ones I don't know are acceleration. So a little bit of algebra. We got 20 newtons plus 8 kilograms plus 2 kilograms. I know newtons really is kilograms meters per second squared. Kilograms cancel out with kilograms. I got to feel like I did the right thing with my acceleration, and I get, you can't see it, 2 meters per second squared And now I can take this value, and it's got to be the mass of the 8 in acceleration. And so that's 8 kilograms times 2 meters per second squared. That is equal to 16 newtons, which is multiple choice question C. And all my units worked out, so I feel pretty good about what I have.